I probably have, I think, the coolest, literally the coolest job in the world at Google. So maybe I'll just put a mobile on. My job is kind of 50% engineering. I get to spend 50% of my time writing code, writing libraries, supporting the open source community. And the other half is really sort of kind of developer relations, but we like to call it at Google the zeroth customer. And what that means is that I work with a team of 25 engineers or so. We build a product that 1 million plus people use, but I am the first customer, meaning it's my job every time we come up with a new API or a new API idea or a change to an API, it's my job to figure that out. Does it work for me? Does it work for the rest of our community? I am that sort of interface between the kind of Angular team and the greater outside world. And for me, it is literally, I would be doing this job for free if they weren't paying me to do it. Don't tell my boss that, but I would. So being a DPA is something that a lot of what I do is talk to teams. I talk to internal teams and external teams. And Angular has gone through an evolution over the past, 8 or 9 years at this point. And we've gotten to a point today where I think Angular is a really, really good framework for building what I would call an application. That is, you own the whole page. You are writing something like Gmail or Inbox or Facebook or any kind of application where you own the whole page, right? Angular is a framework that's pretty good at this kind of thing. I should have told you I was going to walk around and move. Right, so we're good at this. This is what our tooling is about. This is what our documentation is all about. We've made a lot of effort to get Angular very, very good at building apps, right? We like to name drop this one. This is because we're at a Microsoft building. This is Microsoft's new Windows Admin Center. This is an Angular app. It's all written in HTML5. It's kind of hosted and served by Windows. So this is the kind of thing that we're really good at, right? This is our bread and butter. But Angular is not so easy to use, or historically has not been so easy to use in places that don't maybe fit this SPA model, right? And while those of us that live in Silicon Valley and get to work on shiny frameworks all the time, we think everybody's building SPAs, right? The reality is that most of the people in the world who are building web applications today are maintaining legacy applications, right? They don't all get to use all the new hotness all the time. So a lot of the discussions I've been having over the past year or two on Angular have been talking to teams about things that are not SPAs, right? Not your traditional React or Angular or Ember kind of style application. And the first one that comes up for Angular all the time is this idea of like, well, I already have an HTML page, right? I'm using ASP.NET or some Java thing to render standard HTML, right? And then AngularJS back in the day, that's Angular 1x, let you kind of just sprinkle interactivity in the page, right? You could put this magical annotation on the page, and Angular would boot up, and it was this magical, shiny thing that everybody loves. And it's great, right? But there were performance issues. There were a number of issues about that. So when we released Angular 2, we pulled a lot of that out, right, to focus on this case of building single-page kind of root applications. We hear about this all the time. This is literally the most requested feature that we get is like bring back this interactive sprinkling functionality that we wanted. And the key point about this, right, is that Angular or React or Ember or whatever, its mental model today is really that it owns the entire DOM of the page, or at least owns the entire DOM from a single root node. Right? And this is kind of the way we all think about them today. CMSs are another one that come up all the time, right? Like a CMS is sort of the antithesis of what a single-page application is, right? You have a database in the back end that's managing content. You have people who are not necessarily developers assembling pages together, right? They're not writing code. They're configuring pages. They're dragging and dropping. They're WYSIWYGing, right? This stuff typically comes from server-side environments, right? It's usually driven by layout or attributes or like settings. It's a very lightweight configuration thing. Again, doable with something like Angular, doable with something like React. You can do these kinds of things, but they're not easy, right? It's a non-trivial thing to do. And you have to know quite a lot about React or Angular or whatever to be successful at this. And this is the big one, like widgets, right? And the definition of a widget is a very broad thing, right? But I would call it like a mini app. And that can be anything from a date picker. Raise your hand in this room if you've ever written a date picker. Raise your hand in this room if you enjoyed writing that date picker. That's none of them for those of you watching on the home screen, right? So date pickers, right? We're redoing them all the time. Everybody's rebuilding widgets all the time. We're all duplicating our own work. And this isn't really ideal. We get into teams like, I've been talking to the Microsoft SharePoint team. And again, if you'd asked me 2 years ago, are you going to be working at Google talking to the SharePoint team? I would have told you you're a crazy person. But I do it, right? And so they're coming to us and saying, look, we have developers who want to use Angular, right? We want to use this cool thing that you've built, but we can't figure out how to plug it into this existing SharePoint kind of CMS thing we have, right? But people want this. This is the kind of thing we hear about all the time. And I think in the context of this audience, everything that I'm saying about Angular, you could replace Ember or React or Vue with, right? All these teams, we're all having the same conversation, I know, because we're talking to these teams. This is the world we live in, where we're building kind of SPA frameworks. They're really great. But all these people have all these use cases that we're not necessarily thinking about, right? And the last one, and this comes up all the time, is, OK, when AngularJS started 8, 9 years ago, there were only a couple of frameworks around. There was Backbone. There wasn't much out there. We live in today. There are a dozen frameworks, right? And the joke is there's like a new framework every other day, right? I personally think this is great, right? Like the more stuff that's happening, the more innovation we're seeing, whatever. It's good that this is happening. But it gets worse, right? Because you're working at a company where, well, you used to use AngularJS, or you used to use Backbone, and now you want to use React or Vue. And now you're dealing with 2 or 3 or 4 different concepts on the page at the same time, right? So not only are you using a framework that's maybe not necessarily built for this kind of widgety mixed content, right? You're also then having to understand 4 of these frameworks at the same time. And again, this is not ideal. It's doable. It's possible. But it's not great. We have this problem at Google as well. So many people don't know, we actually have like half a dozen frameworks inside of Google. The 2 most famous ones are obviously Angular or AngularJS and Polymer, right? These are the big ones you know about outside. There's another version of Angular that almost nobody knows exists, and that's Angular Dart. Same framework, different language, same templating. That's used a lot in ads. That one at the end there, Wiz, right? Wiz is the thing that's used to build things like Inbox and Google Docs. It's a very, very kind of server-side first framework. And it's awesome, right? And again, Google, like any other big company, has teams that are moving off of one of these onto the other one, or they're sharing code, or you have 6 different teams in 6 different locations who all want to use their own different things and assemble them into these applications, right? And of course, then we buy companies. I talked to a team the other day who's using Preact, and we want to support them, right? We don't want to say everybody who comes into Google has to rewrite all their stuff in a Google product. So we have this problem. We're mixing this stuff. We're dealing with all of these different frameworks and really not able to do it in a very nice way. And for me, the biggest kind of problem, and there'll be a talk a little bit later. I think maybe the next talk actually goes much more deeply into this. But for me, this is the crux of the problem. And this is a sort of realization that I had a year or so ago, where I went, this is the problem that we have, and maybe we could do a better job of this. So what we all want to do is be able to write this, right? Everybody knows how HTML works. I write a component in whatever language I want. I want to put it on the page, and it works, right? In reality, what it looks like is something like this. So this is Angular, right, where we are bringing in some sort of render method from Angular. I've written an Angular component elsewhere, and I'm saying render this component onto the page. What's actually happening under the hood here is Angular is saying, OK, I want to find this DOM element, right? Like this is already on the page. As far as the browser is concerned, this is just a div, right? It doesn't know anything about it. It's just a div. And then Angular goes and finds this element and kind of glues them together. Looks like it's an Angular. If you've done React, fundamentally the same thing, right? I have some class, some component, some bit of logic that I've written in some framework. And I'm going to say, take this bit of logic and connect it, mount it, bootstrap it to the node that I care about, right? Everybody does this probably every single day. Maybe you don't think about it, right? And again, if you're building an SPA, you only write this line of code once, and you forget about it. You never ever think about this line again. Cool, I don't have to worry about it. We can be a little more specific. Angular has a slightly more detailed syntax. But again, same thing. Like I want to take this component and connect it to this node on the page, glue them together. So this is fine. What about when you want to do this, though? What if you want to configure it, right? You want to put an attribute on this page. Well, now the framework that you're using, Angular, React, Vue, whatever, it doesn't know anything about that attributes, right? What if you want to do 2 of these things? Well, you have to go change the code that's booting up the page, right? Well, I have 2 elements now, so I have to do 2 of these manual steps to connect the element to the node or to my component, right? Or, what if I have 2 different ones on the page? Hello world, I want to do 2 of one or half a dozen of the other. Or I'm using a CMS where this happened, like what elements are on the page are being decided at runtime on the server, right? You can't rewrite the code that bootstraps the page just because the HTML has changed. So we hear this a lot, right? Well, like, why are you using a framework? Just use the platform instead, right? We've already solved this problem. Web components, right? Raise your hand if you've heard of web components. Almost everybody in the room. Raise your hand if you're using web components. 2 of you in the room, 3 of you in the room. Raise your hand if you've ever written a web component. 2 of you, 3 of you, right? So that's, let's call it 2% of this room, 1, 2%. And I think this was a really interesting question for me. I joined Google kind of bright-eyed and bushy-tailed, going, oh my God, we're going to change the world. Web components are great. Everything's amazing, right? But why are we using frameworks? In Angular, at least, and in every community, right? It's because we're doing all this stuff that's not about web components, right? We're doing forms. We're doing business logic. We have routers. We're talking to servers. We're internationalization, right? We've got to think about PWAs. All this stuff is the stuff that you need to build applications, right? This is not a replacement for web components. Web components don't replace HTTP. They don't replace internationalization, right? So the problem comes is a little bit, web components is this idea, right? This is the definition of a web component. The key things I want to point out here, number one, we're talking about custom reusable into HTML tags that are usable in any JavaScript library or framework, right? Nowhere in this paragraph does it talk about internationalization, forms, all the other stuff that's hard about building web applications, right? So we get into this problem where we've kind of built up this straw man where we have this idea of web components, and maybe Google, we're guilty of this, saying, oh, they're going to change the world. They're going to solve all your problems. You don't need a framework. Just use the platform, right? And then on the other side of the table, you hear the React community, the Angular community. We look at web components, and quite frankly, I think a lot of us don't buy it, right? Polymer team, or the Google team says, hey, this thing solves all your problems. And because we're suspicious, we're all developers, we go, you're not going to solve all of my problems, since we write the whole idea off, right? And that's why, for me, there's only 2 or 3 of you in the room using web components. They've been around now for 4 or 5 years, but nobody's using them, right? And I think we've done this sales pitch for a long time that says they're going to solve all your problems. The first time you try to use them, they don't solve all your problems, and you forget about them. You write them off, right? And I think this is a shame. But for example, I don't think Michael's wrong here, right? Like, he is absolutely not wrong that web components are not talking about anything that React is doing, right? They're not talking about functional reactive programming. They're not talking about JSX. But I actually think this is a feature, not a bug. And this is what I want to talk about in the talk today. This is the other thing, is that when we all talk about using the platform, what happens, I think, is the framework people, and a lot of that's the teams, but also the users and the communities, we get defensive about this stuff, right? I love Angular. I don't want to use web components, right? I don't need web components. And so unfortunately, I think we've gotten to a really bad PR situation. So I'd like to propose maybe a different way of thinking about this. So, and I think actually there's a talk maybe called Web Components later, so I'm sorry about this. But I'm going to propose that we're just going to stop using the word web components, because they're a straw man. They're not helpful to people. They don't actually tell you anything about what you're using. And unfortunately, they've become this idea that's easy to argue against, and we kind of get lost in the weeds of thinking about what we can actually do with this stuff. So let's break this down a little bit. Web components, the idea, is actually 4 APIs. And there are 4 APIs that are fundamentally not really related to each other. You can pick and choose. You can use one of these. An argument that I got into in my first day at Google was, if I build a component that uses Shadow DOM but doesn't use custom elements, is that a web component? I would say no, but you could argue either way. So this idea of like, what is a web component? It's not helpful for us. And so these are the things that I think we should be talking about. These APIs, which do one thing, right, are a low-level API, and I think are extremely useful to those of us writing applications using frameworks. But I think we need to maybe reposition how we think about these things a little bit. And so I'm going to do a demo today. I want to talk you through what we're doing on Angular. And my hope is it'll make you think slightly differently about standards, about how this stuff works, and maybe get to a point where we can actually start sharing code between these teams, sharing ideas between these different frameworks. So hopefully, we don't all have to build the same date picker 10 more times, right? Just a note, this last one, HTML imports, this is probably the most contentious of the web component specs. You've probably never used it unless you've been using Polymer. And even the Polymer team last month decided HTML imports are dead, nobody's using them. So really, that last one, forget about it. It doesn't exist. It's going away. So we don't have to worry about it too much. The one I want to talk about today is custom elements. So this, to me, is the crux of web components. And that's the last time I use the term web components. But this is the real magical bit of this spec. So custom elements are really, really simple. There are basically two parts to them. You have a class, which extends from an HTML element. This is the standard HTML element that's built into your browser, right? This is the thing that everybody uses. You can extend from a button or a div or a span, but in most cases, you're going to extend this HTML element. And then what you do is you use this custom elements define API. This is now baked into the browser, and you basically say, when I put something on the page that is hello-world, then I want you to start up, create an instance of this hello world class for me, right? Very, very simple. And so basically, at the lowest level, these two lines of code will give you a custom HTML element. So every time you put that thing on the page, that we'll get a new instance of that node, and everything will kind of start up and running. Custom elements come with lifecycles. So basically, when the element is connected to the page, whether that's programmatically with you doing it, or you've done it in the index.html page, we give you a callback. When it gets pulled out of the page, you get a callback. We can ask, or we can tell the browser, we want to observe these attributes. So if we look at that name attribute that I put on the DOM node, we can say to the browser, I care about this attribute, and I want you to tell me every time it changes. And so that attribute change callback fires anytime the name attribute changes, right? And so what we're saying is, these are the attributes that I care about. Anytime any of those are changed or edited or modified, then just tell us in our callback. And if you squint, this looks a lot like an Angular lifecycle event, ng on changes, or a React lifecycle event, right? Component did mount, component will mount, whatever they're calling it now. Similar idea, right? Similar kind of thing. They can have properties. So we're setting kind of two custom properties here. This is a setter and a getter pair. So we actually use this by just saying this element dot foo, right? This element dot name, like an object or array or any JavaScript value that you use, right? And so what's important here is that the thing that we're looking at is just an ES6 class. There's nothing special about it, and all the things that you can do with ES6 classes today, you can do with a custom element. They can also fire events. So in the same way that you can take an input event or an input element or button and listen to clicks or drags or input events on it, you can dispatch events from these components that will kind of bubble up to the outside world. So the problem we got to thinking about in Angular was, OK, we've got this really powerful low-level API that does some things that actually you cannot do in framework land, right? There's no way for a framework without polling to watch an attribute changing in the DOM, right? There is no way for a framework to know at the node level when a thing has been inserted or removed in a nicely encapsulated way. Again, APIs exist to do this. It's possible, but it's not very conceptually simple. So we got to thinking about this problem, and we kind of decided, OK, can we glue these two things together in a way that solves the problems that we have, but doesn't kind of change the fundamental nature of something like Angular? So again, let's go back to our idea here, right? Like, we want to be able to just do this, put a tag on the page, and kind of have this start up our application, have this actually do the work. So we shipped a project in Angular 6.0 called Angular Elements that actually does exactly this. That's the sales pitch, right? But I'm going to kind of show you the super light, kind of hand-wavy sketched version here, also with React, right? So hopefully we can get the concepts clear. And then, of course, Angular kind of handles all the dirty details for you. But what we're going to do here, you could do with any framework, more or less. So what we're going to do here is we've got a couple different things. I'm pulling in my standard render method from the Angular project. And I'm pulling in my hello world component. So this is the same stuff we've already looked at, right? And literally all I'm doing is basically saying, when this thing is connected to the page, call my render component method. And rather than saying document.querySelector, that thing on the page, right, we're already inside of the elements, right? Because we've registered this node as a custom element, this, in this case, is that host node, right? This is the same thing that would be returned from document.querySelector. Right? But we're already there. We already have it, because that's part of the class that we're writing. So then we can just put the thing on the page, and it would then self-bootstrap or self-mount, if you prefer. it would look more or less exactly the same in React. So again, we've got React DOM coming in, we've got a React component, and all we're saying again is when this class gets connected to the page, tell React to do its normal thing, right? But what we can do here is, because this is self-encapsulated, because we're not saying from the outside, connect this node to this, this custom element class, it's happening internal to the element, we can put as many as we want on the page, and they will self-bootstrap. So if I want to do 2 of them, or have a hello world and a goodbye world, that just kind of works for free. Works for attributes as well, so we can basically say hello name, actually add the configuration in the HTML. Again, this is really useful. You have a CMS, it's going to render this page out, right? You can do settings, you can do configuration on your server, and this will just pick up and render. So in Angular, it looks something like this, right? We're listening to that attribute changed callback, and really just updating the outside value into our component class, right? We're acting a little bit of a proxy here, if you like. Every time a value gets set on the outer class, the host, the wrapper, we're just propagating it into the Angular context and updating the Angular application. So importantly here, we're not changing anything about how Angular works fundamentally. It's a standard Angular component. We're just putting it in a slightly different host context. We're wrapping it up, packaging it. And I was at a conference a couple of weeks ago, and somebody actually asked me this, and I hadn't thought about it this way. But they said to me, well, are you talking about basically containers, right? And really what we're talking about is the same thing that's happened with containers and servers and Linux, right? Where everything is a container. You don't really care about what's happening inside of the container, because you have mechanisms now like Kubernetes that manage containers, right? This is a very similar concept for the browser, right? So you can do whatever you want inside of this container, inside of this element. It could be Angular, it could be React, it could be Vue. But on the outside, it's a completely standard DOM API. And importantly, that means that anybody can consume it without having to know anything about how it works. So again, simple property setting. And then we can just put the thing in the DOM, right? So this is completely standard vanilla JavaScript that if you've done any web development at all, this is probably the first thing you did as a web developer, right? Other than maybe doing an HTML. You create an element, you put it on the page, right? And then you can set properties on it. And now, this works exactly like you'd expect it to. So what we've done is taken this kind of custom Angular abstraction, packaged it up in a way that is completely standard, and that way anybody who's consuming it already knows how to use it. They already know how it works. They don't have to know anything about your framework. We do the same thing here with setters and properties, right? So this is a setter setting the name value. If I set from the outside, we'll just propagate it to the components. Set attributes this way, right? So these are just completely standard DOM APIs. Is that iTunes complaining at me now? Great, thanks iTunes. It's gonna never buzz at me again either. Let's go back to our thing here, cool. Same thing with events, right? So hello world.add event listener, again, completely standard DOM API. You would also do the same thing with click or drag or input, right? So I'm going to say this probably 10 more times in the course of the context here, right? But what we're doing, quite simply, is taking the thing that you already know how to use as a framework developer and making it available to anybody who's consuming it who may not be a framework developer, may not know anything about the tech that it's written in. Don't know why my doc won't go away now. Thank you. Awesome. So here's a word that makes everybody cringe in a room full of non-Angular developers, right? So this is the thing that Angular does. We love dependency injection, right? We love it. We put it everywhere. It's great. You maybe hate it. But again, like they're not necessarily mutually exclusive, right? So we have a whole stack of injectors. This is how kind of Angular works under the hood. We have this injector at the top, which has the platform level stuff. Your individual application services kind of live in their own modules. So we have this whole DI system. I really love it. A lot of people really don't love it. That's fine. It works exactly the same in custom elements, though, right? But if you think about this, here's this problem, right? So we're using this existing DOM API, document.createElement. And really what I'm able to say is I want to inject a value into this element, right? I want to be able to pass something into it. In a React context, this might be props. You want to pass in props to your component. Right? But you can't do it here because there's no API to do that, right? This API has existed for 20 plus years, and there's no way to put a second argument in the end there to pass extra values in. So custom elements gives us this new API, which basically says, let me ask the registry that I defined this custom element on, give it back to me as a class, hello world element, and then I can just new it up, create a new instance of it, right? This then becomes extremely powerful for doing all kinds of much more complicated things, right? If you have some crazy dynamic dashboard-driven framework, as we've all built, and I've seen 100 of them in this week, right? This allows you to do very powerful composition with, again, all you're doing is creating new classes. You don't have to know about React or Angular or Vue. You are just creating new instance of this thing, this element in the browser, putting it on the page, and it works exactly as you'd expect it to. This allows you to pass things in, right? So in this case, we can pass in a different injector to do different Angular contexts here. You could also pass in props, right? If there's a React component, you want to do props or services or whatever. It's completely flexible because it is just an ES6 class. This is known by another name. Raise your hand if you've heard the word transclusion before. I love that nobody knows that word. So transclusion is what we used to call content projection. The basic idea of something like transclusion in a framework like Angular is we're going to write a template like this. And what we're going to say in this template is there is some space in the template that I'm going to insert content in from the outside world. So what this looks like in practice is I take an element like this, hello world, right? And what I want to say is I want to inject some content. This is the span coming from the outside world. And importantly, this is what you would write on the index.html page, right? As the author of the components, you don't know anything about what any is going to give to you to render. A good example of this that may help is cards, right? You have a card or a panel or this kind of bootstrap style thing. What you as the framework author or the tools author, you want to be able to say, here's the card, and this card has an API that you can put stuff into. Right? This is what content projection is about. So again, template looks like this. Put it on the page like this. This is the content that we're going to put into that page, and the final result looks something like this. Right? This is just content projection. Angular's done this for a long time. We still call it transclusion. It's extremely useful. I'm going to put an asterisk here. Because the second API that was on that list, Shadow DOM, right, they introduced this same idea. So Shadow DOM is this exact idea where we can have an encapsulated component, define slots that say, from the outside world, we're going to take content, we're going to project it into these slots. So that looks like this. You have a slot rather than ng content. This is a completely native API now. And anybody who uses this component and puts stuff as a child of it is projected into that slot. Again, cards, panels, anything that's kind of a UI wrapper element, this is really, really useful for. Looks like that. That's right. So slot API. Compose some content into it. So this span is inside of that hello world. We can also have named slots. So we can say if we have a header and a footer or a main and a content or whatever, we can from the outside world say, take this node and project it into the main, and this node and project it into the footer. Looks like this. So the span goes in there. We name the thing. We have default content in there, and it gets projected into that parent slot. So again, I point this out not because you need to know about the vagaries of ng content or transclusion. This is the kind of thing that you as a web developer, somebody writing HTML, does every day without really thinking about it, right? And you want people to be able to consume your shiny fancy cards component in a way that they expect, right? In a way that they'd expect that I can put content in the child of it and it's going to end up in the right place, right? If you're using something like React or Angular where we own the whole DOM, we wipe out all that content. So you kind of have this problem where you can never put that span slot in there because Angular will always wipe it out. React will always wipe it out. Having slots, transclusion, allows us to compose these things dynamically at runtime. We don't have to know anything about them to make these things very, very reusable. Let's do a quick demo of this, if I can get my clicker to actually click to the right place. This is using Stacklets. If you've never used Stacklets before, it's awesome. Highly recommend trying it out. So this is running Angular and TypeScript and all the goodness in the browser. Just poke around the code here real quick. So I have a very simple Angular component here. It's got a selector. It's got a template and some CSS. And it's got, right now, just a very simple input that says we have a name value. If you're not an Angular developer, @input here is effectively the same as a prop in React. Right? We're basically saying this is some value that from the outside world we're going to pass in. We register it, and if I get this up and running here, what we've got is kind of exactly what you'd expect, right? So we've got an element on the page. If you look at the source that's come off of the server, just to show you that this is normal stuff, right? So the index page looks like this. There's nothing happening on it. And then when it actually boots up, it looks like this, right? This is the thing, though, that blows my mind. And if you've never tried to do this in the browser, this is something that you don't almost know you're missing, right? So our My App thing on the page now, if this was a normal React app or a normal Angular app, again, we don't know anything about this attribute here, right? We don't know anything about it. And so if we changed it, nothing would happen, because Angular by default and React by default, they're not glued together. They don't have that attribute changed callback that we were showing earlier. But because we've integrated these two things, now I can just get into the DOM and say, you know, hello, BuzzJS, and it updates, right? And like, if you're a framework person, this is sort of almost a little bit interesting, because this is not a thing that you expect to work. But if you're an HTML developer, right, all you've ever done is HTML, you would expect this to work. And so you get in this uncanny valley where you've got this super high-tech, powerful framework, but it doesn't work like the simplest input or div or span or button, right? And so what this is really beginning to do is glue together these concepts and get rid of this uncanny valley, if you like. We can go a little further with this. And I can just get in the browser and say, let's create a new one. So I'm just in the console here, not doing anything interesting. I mean, document.createElement. I call that my app. I think I did. Yep. My app. So now I've got a new element. New L. There we go. So it's just an element, right? I can document.body.append child. New L. Ends up on the page. I can do things like this. I can say new L dot name. You can see I get autocomplete. I get all the type completion stuff you'd expect. All right. You can set attributes on it. New L. Right. And so importantly here, all the same Angular, shiny data binding, all that great stuff that we use frameworks for is happening inside of the component. But from the outside world, I don't care. I don't have to do anything about it. It just works exactly as I expect it to. So just to run through some of the use cases, why we care about this so much. Like I said, CMS pages, dynamic components, hybrid rendering, where you want to sort of do half of your rendering on the server, half your rendering on the client. Very powerful stuff. The one I want to call out is Angular.io, because this is really interesting and abstract, right, this problem that I'm talking about. But do you actually have this problem in the real world? And we do on our own website, which is why we started pursuing this. So if you go to Angular.io, this is the preview version. Angular.io is an Angular application, right? So we've got the Angular router in here. The nav bar on the left side is driven by Angular. But of course, it's a documentation website, right? Angular.io is our docs site, and it's got 10,000 documents that are 100% HTML. So it doesn't make sense to take any of those components and like take all this kind of static HTML and run it through Angular, right? It doesn't need to know about Angular. Angular doesn't give you data binding. It's just HTML, right? But our docs have these embedded widgets, right? We have these little islands of functionality that have, you know, tab panels or code highlights. The tab panel here, right? So we want these little interactive widgets inside of our docs. But of course, our docs, you know, there's 10,000 of them. They're written by a bunch of different people. Some of them are Angular developers. Some of them are purposely not Angular developers, so we get a different perspective, right? And if every single one of these times we wanted to write one of these new pages, we had to write that crazy if switch statement that goes and finds all the appropriate elements, pulls them out, and manually bootstraps React or Angular into them, it's totally not sustainable. And we tried it, and we did it for a while, and it's just awful. So about a month ago, we shipped the first version of Angular that's using custom elements, and we got to delete like 2,000 lines of glue code. It's the best kind of way to do things. So now, all of these widgets on our pages are basically just defined as custom elements, right? We have an Angular component inside of them. They do what they need to do. But the author of the doc, the person who's writing this big piece of HTML that takes the whole page, right? All they have to do is put tab panel on the page, and it just boots up and runs. It's pretty cool. API list, this is a custom element as well. So we were actually a little bit scared when we tried this, and it's been in production now for 6 weeks or so, and we've had 0 issues. It works for everybody. It works in IE. We're kind of impressed that it actually works. You can actually poke through this code on the Angular website if you want. So all these folders are various Angular components that have been converted to or just wrapped up as custom elements. So location and little expandable panels and our live examples. All these things are custom elements now. So that's a useful resource if you want to check that out. Like I said, containers, this idea of taking any app, going to go to any context, containerizing it so other people consume it is really what we're talking about here. We're working with the SharePoint team right now to add this to SharePoint. So you can just drop Angular components into SharePoint. Pretty cool. Reusability. Reusable widgets is the kind of the big thing here, right? So cross-framework compatibility means you can just write a date picker in React or Vue or Angular, spit it out as this custom element, and then you consume it in React or Vue or Angular, and it just works. We maintain on the Angular team, I don't know, we have about 25 material design components now. We own them. They're super accessible. We do all the right things for them. It would be really super cool if we could take those and you could use those components in a non-Angular app. This lets you do that. And the other one we hear about a lot of times from people is design systems. So a lot of big companies, big enterprises, big orgs, they have a team whose job it is to do design, right? They maintain a style guide or a style Bible. But again, they're going to re-implement all of those styles in the 4 different frameworks they use in the company. With something like this, you can write it in one framework, whatever framework that is, export them as custom elements, and then all the other frameworks can consume them. So you're not doing the work 4 times. Just a quick note on support and production readiness. We started on this project 6 months ago because we knew it was more or less the right time. At this point now, all of the big, except of course, Edge has shipped support for these things. We are trying very hard to convince the Edge team that they should care about this. There is a user voice issue on the Edge website. If this is something that interests you, go upvote it. It's already today the most upvoted Edge issue, so hopefully they'll fix that. In the interim, you can polyfill back. There are a couple sets of polyfills. The Chrome team maintains one. It works all the way back to IE9, so you can use those for sure. Polyfills we like here because it allows you to write kind of standard level stuff. You're not inventing anything new. And as browser support picks up, right, you don't have to just change anything. All you do is drop polyfill, which is nice. For us, Angular, again, we've kind of going on this evolution where we're starting from building SPAs to moving forward to thinking about things slightly differently. Working in a project called Ivy, which is our new rendering engine. This is the really meat and potatoes of it. Smallest Angular app you can build today is 36K. This is not even easy to do. This is very hard. Basically, the way our boss inspires us, he bakes cakes for us. So he told us like a year ago, if you can get Angular under 10K for a Hello World, we'll bake you a cake. We went a little bit further than that. And so the Hello World version of Angular today is 2.7K. It'll be coming out in about a month and a half. So this makes it really actually realistic to write an Angular date picker, right? Which you don't want to ship a meg and a half of code to use a date picker. If you have 2.6K of code, nobody cares, right? You have an Angular component. It has all the stuff it needs baked into it. You ship it out, and anybody can consume it. No worries. So we're going to simplify Angular a little bit further. So this is a very simple component model. Rather than you doing the manual connection right now, which our library does for you, we want our compiler to do this for you. So you just say custom element true. It will spit this out. Very simple. We want to make this more flexible. So rather than using decorators, which is what I've been using here on these previous slides, we'll allow you to do this at a kind of static level. So this should work with vanilla JavaScript. This should work with Babel if you want to use Babel for this kind of stuff. So we want to make Angular increasingly more flexible. So that should be fairly useful for most people. And I think I'm going to skip my last demo. So for us, this is just the beginning, right? This is a very new concept for us. We think it's super powerful. We've talked to all these awesome teams. They're all doing the same thing, Ionic and Svelte team and Stencil and Polymer, of course. Skate.js, if you're a React or Preact or Vue developer, check out Skate because it does exactly what I've been talking about for React and Preact. Right? So it gives you this wrapper which glues together the custom element API and the component API. Angular's on that list now. We're pretty excited about this. I'll be around if you want to come and chat with me. Otherwise, thanks for listening. Q&A?
So we have a few minutes for questions. If anybody has, I can come bring you the mic, or at least we can repeat what you say.
No questions. Cool.
Have to have questions, so that's fine.
Totally fine.
I'm racing over here.
Is there any noticeable performance overhead for the custom elements API?
That's an interesting question. So I like to put it this way. I think that custom elements make sense in the root case, right, where you're going to do this once or twice or 10 times, right? And they make a lot of sense at the leaf level, so a date picker, right? There is a performance cost if you're going to render 40,000 of them on a single page, right? But at the end of the day, what's interesting is that you are already creating the element anyway, right? So because you're subclassing HTML elements, it's not a big hit because you are already having to create those elements on the page anyway, right? You have to be a little bit cautious, and this is the hard bit we did with Angular that Skate does, is making sure that you're not doing too much work anytime the component tells you to. So we do batching and optimizations and things like that. But in general, if you're using the native custom API, like the native elements API, it's like 5% slower is the numbers we've seen. If you're using the polyfill, that's a significantly higher cost, right? But in modern browsers to support it, it's a very low cost thing to do.
I just had a question. This might be a higher level question, but when one issue with sharing web components across applications is the difficulty of overriding styles. Do you have any thoughts about how you could use this approach, but still have some style customizability so you can share function?
And this is a good case where like your natural reaction is, well, but web components have this styling thing with shadow, and that's not the case, right? Shadow DOM does have this problem, or they would call it a feature, right? In Angular, all the stuff that I showed you, we're not using Shadow DOM at all. We're just using custom elements, and we're using Angular's completely standard styling model, right? Which is just CSS based. It also means that if you wanted to do CSS and JS, or JS and CSS, whatever the cool one is today, you could do that, right? Like you don't have to use Shadow DOM to use custom elements. There are some proposals you should read if you like the part and theme proposal, which is designed to solve some of the issues with Shadow DOM to make theming a little bit easier, a little more sort of more sane to do. But in the interim, we're saying to a lot of people, don't even worry about the Shadow DOM side of this. Just do styling like you're already doing, right? Like you've already done with Bootstrap for 5 years. And if and when Shadow DOM makes sense for you, then switch it on, right? But it's not required to build a custom elements, which is why I don't say web component.
Thank you very much. Let's hear it for Rob. Oh, I think we're out of
I'll go
time
touch him
now.
after.
Sorry.
Chat with me after.
Thank you, Rob.
Great. Thank you.